Good evening, folks. All right, first off, my apologies for not having a screencast ready for you guys sooner. It's been a little crazy of late. Hopefully, everyone's holding up okay and dealing with good old COVID 19 and all the situations that add a lot of stress to our lives because of that. I do miss seeing you guys on Wednesday evenings. Certainly, teaching in person is obviously my preference, but hey, we're making do. Okay. All right, so I did do a screencast for you, just the introduction to users and groups. This time I'd like to take that a little farther and get into file access control lists, get into the set group ID bit, a little more advanced user and group administration. First off, I'm going to show you how to remote console into another box. So right now I'm just sitting here on my MacBook Pro. From work, by the way. I don't have that kind of money to be buying a MacBook Pro. So kind of using a work machine, and I have a VM spinning. So instead of me actually just using the screen part of the VM, I'm going to show you kind of how we work in the real world. And that is actually using the SSH command. So SSH is actually how you gain a remote shell console. Now SSH, of course, works if you happen to be already on a Unix or a Linux-like operating system and you actually have the secure shell command to log into a Linux box. If you happen to be on Windows, you'll have to use some other tool. One that's popular is called PuTTY, which, well, if we were at school, I could show you. But because I'm working with what I have, and I happen to have OS X, I'm in a bash shell right now, so I'm just going to use the SSH command, and then I went ahead and bridged my network, so I'm going to log in as student. Now, obviously, this is my IP address is going to be different than what yours is. My VM, when I spun it up and I bridged the network, my router gave it an IP address of 192.168.1.182, which is an internal facing IP, means nothing to you guys at home. It just means that if you were at my house and you were trying to get to my VM running on my personal network here, that is the IP address of my VM. Pop in the password like usual. All right. Now, just a brief review. I'm going to go ahead and stretch out my console. Oh, that did not work the way I wanted to. All right, so just a brief review. Users and groups. To make a user, we use the user add command. User add, and then the login. So if we wanted to add a login of Steve, you just say user add Steve. Now, of course, can I run user add as the student account? No. If you're going to take and do user and group administration, you either have to have privileges in the sudoers file, which some of you did some research on, or you need to be running around as root. So what I'm going to do is sudo turn myself into root. And then now I can take and say user add Steve. All right, now at this point in time, Steve has an account in the box. Now, can Steve actually log into the box? No, not yet. Well, why? Well, he doesn't have a password. So we need to set a password for Steve. And set his password. Now, if you're root, it will let you set bad passwords. It claims that the password is bad, but you can still retype it anyhow. And if you're root, it'll still take. All right, so now Steve can actually log into the box. Now, we need to put Steve into a group. Now, I didn't make any groups, and this is a fresh VM, so let me take and do a group add, and let's say Steve is going to be a sysadmin. So I'm going to make a group called sysadmin. Now, in this case, we've made the Steve account. We then made the sysadmin group. Since Steve already exists, I now then need to modify his account to put him inside of the sysadmin group. So now what I'll do is I'll do a user mod. We're going to append the group. Notice the capitalization, lowercase a for append, capital G for the group. And then we're going to append the group of sysadmin to who? Just Steve. All right, now we're going to check Steve's groups by using the groups command. So it shows me that Steve now belongs in his private group as well as the sysadmin group. Now, if the group already exists, which is what I had done in the previous screencast, you're going to take and kind of kill two birds with one stone. Let's add another sysadmin. So we'll do a user add. Now this time we're going to say, you know what? We're going to say the group is going to be sysadmin. And who are we adding? And this time, let's make another sysadmin. Oh, work with a guy named Brent. So Brent is also going to be a sysadmin. And what we did here is you'll notice in comparison, you don't have to do the other options. So like when we did user add Steve, it just made the Steve account, but then we had to go behind it and do a user mod. Now in this case, we did user add with a dash capital G, saying it's going to be going into the sysadmin group. So now if I take a look at my groups, Brent is also a sysadmin. Okay, now speaking of groups, how do you know who was in what group? Well, I guess the long way is to try to figure out, well, how many different logins are on your system. Well, there's a way to find that out. The easiest way to see who belongs to what group is to actually look at the Etsy group file. So we did this last time as well. So if I take a look at the Etsy group file, it's just a text file named group inside the Etsy directory. At the bottom of the file, those will be the groups that we've manually created just now. You'll see that there's a sysadmin group, and the members of that group are Steve and Brent. Easy enough. Okay, now, let's see here. The demo that we were working through is we did a make directory of my company, and inside of my company, we made some directories. I'm just going off a rough memory, so I think there was like maybe, let's say there's a docs directory, a web directory, and a SQL directory for the DBAs. All right, tree. Okie dokie. And again, if the tree command is not there, you can always do a yum install tree if you're missing the tree command. Tree is kind of handy. So now if we go back a directory and run the tree command again, oh, now you'll see the tree command now is going to traverse a lot of stuff. Well, why is that? Well, right now I'm in the top level directory, so that's not very helpful. So inside of my company, there's that. So if I run tree, boom, there's the subdirectories. Okay. Now, to review long listing, you'll see here that because I created these directories as root, root by default owns them. Now, for our sysadmins, let's say our sysadmins are going to be responsible for maintaining documentation. So we're going to change that. So we're going to use the group command to change to sysadmins. And what are we changing? The docs subdirectory. Oops, sysadmin, sorry. No S. All right, so long listing. All right, so now you'll see that the docs directory is group owned. That's what this field is here. This group owned by the sysadmin group. Now, a little bit of a problem still. If you take a look at the octals, all right, the file mode bits over here, D is for directory. We know that. Read, write, execute. That is the user. So that means the root can read, write, and execute within the docs directory. Okay. The second set is read, write, execute. We are missing the write bit, which means that even though this directory, the docs directory, is group owned by the sysadmins, they cannot write in that directory. So it's a little bit of a problem. So we need to fix that. So we'll do a chmod, change file mode bits. And I believe last time we kind of did it the shortcut. The GNU syntax is for the group, we're going to add the write bit to docs. And run the long listing. And you'll see now that sysadmin owns it, group owns it, and the group privileges are open. So now it's not a problem. Okay. Now let's see here. Now we're going to switch users to be Steve. And then who am I? Okay, I am Steve. I'm going to go into the docs directory. There's nothing there. I'm going to vim a new file, and we're going to call it readme.txt. This is just a readme file. Oh, that's interesting. Where's my escape key? That's not cool. Now there it is. Sorry, if anybody has the the pleasure of attempting to use a MacBook, the new one that work just got me, I'm not so sure if I like that bar across the top. I don't actually have a physical escape key to hit, which is a problem. Okay, now let's see here. You know what? It didn't even save. It's terrible. Let's try this again. Wow. It's going to be one of those nights. This is just a readme, escape. There we go. Right, quit. Okay, there we go. All right. Clear. Readme. Now, Steve just made this file. Now, here is the first challenge we have with user and group administration. So Steve made the file. His coworker, Brent, needs to also be able to edit this file. Now, to do so, Steve has a couple options. He can either take and change ownership of it, or Root can change ownership to give the file to Brent so he can make edits. Or rather, the smarter thing is that Steve could take and to group the file itself and say, I'm going to group, and I'm going to change to the sysadmin group. And what am I changing? I'm going to change my readme file. Now, notice that Steve was actually able to use the group command. Right? Certain commands can actually be run as an end user. However, in order for the group command to work and be allowed to be used by Steve, he can only group things to groups that he belongs to. So because Steve is a member of the sysadmin group, the operating system will allow him to run the group command to change other files and directories to also be group owned by the sysadmin group because he's a member. Now, if he's trying to change membership, change the group membership to a group that he does not belong to, obviously that is not going to work. So it's one of these built-in features. Long listing, so now you can see it's owned by the sysadmin group. So if that's the case, what I'll do now is I'm going to switch users to Brent. And Brent's going to go into docs. Oops. There's a readme file. He's going to attempt to edit the readme file. And this was added by Brent. All right, there we go. Long listing, and even though Brent made an edit to the file, Steve still owns it, and the sysadmin group owns it. But now Brent is going to make another file himself. The readme file, and I don't know what I'm going to call this next document. Another doc. It's going to be one of those nights. Another doc. Text. This is another doc. All right, now keep in mind I'm Brent, and Brent made a new file called another doc, and now Brent has kind of the same problem that Steve had. Steve needs to make edits to this text file, but he can't right now until Brent remembers to do a group command on the document to switch it. All right, so now Brent's going to have to remember, oh, wait a minute, I got to do to group to sysadmin against my file. All right, now at this point in time, because the group privileges are set to read and write, and it's group owned by sysadmin, Steve can make edits. Now, this manual dependency on people remembering to run the group command is probably not a good idea. So this is where we introduce what they call the set group ID bit. Now, I guess it's probably a good time to kind of go down the rabbit hole and talk about the chmod command more. So far for chmod, we've done the simple stuff. We've done chmod plus X to add the execute bit. I've shown you chmod G plus W, which is another, say, the group needs to have a certain bit added to it. The other way to do chmod is using what they call octals. Now, did they actually go into the octals in this one? No, not on this. The other thing, too, is that there are more than one man page. If you go to the bottom of any man page, take a look to see if there's another C also. So if you see here, it says C also chmod with a 2 parenthesis around it. So now if I say man 2 chmod, it's actually going to bring up the second man page associated with chmod. Now this one's going to be a little more focused towards developers. You'll notice it's the Linux Programmer's Manual. And it goes into more things that look like they're kind of C-based, of course. But the part I want to skip to is understanding what these digits mean. 4 is read, 2 is write, and 1 is execute. All right, so what we'll probably do is just so we just keep a little, let's see, I'll make another tab over here. Let's see. New file. So 4 equals read, 2 equals write, and 1 is execute. And again, if you forget what these mean, you can take and simply say man to chmod. Or if you forget that, go into the normal man page for chmod, go down to the bottom of it, and then you'll see a C also chmod 2. So then man 2 chmod. Oops. You guys get the point. And here we are. Scroll down. And then you get to the digits where we say look for the user ones. 4 is read, 2 is write, 1 is execute. So what does that mean? Well, it's a difference of syntax. So I could take and let's say we need to make a script. Okay, so now I have a script sitting there. All scripts, as we've learned, need to have the execute bit set on them. So I could say chmod plus X. All right, now that's the GNU syntax, right? The octal syntax would be 777 on my script. Take a look at that, and you'll notice that now the read, write, and execute bit is set for everybody. Now that may not be the best thing to do, so instead we'll do chmod 7. Now you might be wondering, where the hell is this 7 coming from? The 7 is actually a simple matter of addition. If I want the bit to have read, write, and execute, I simply add these values together, and that's where the 7 comes from. So the user needs to have read, write, and execute on the script. Okay, makes sense. The group owner, because we're in a shared area now, we want also the group to have read, write, and execute privileges, so that's another 7. So then, lastly, everybody else in the system, maybe we don't want them to be able to make changes to the script, so they need to have read-only access, but they still want to be able to execute it. So if you're going to have read access and execute it, you add the two values together. 4 plus 1 is 5. So the first field is the user, second field is the group, and the last field is others. Just remember Yugo. My script. And now if you take a look at the long listing, this is more of an appropriate setting for a bash script. Now, we still have a little bit of a problem that the new file still belongs to Brent instead of automatically being group owned to sysadmin. To correct that, we're going to go up one directory. We'll see that the sysadmin group already has group ownership of the docs directory, which is perfect. We're going to do a chmod, notice the syntax, 2.775 on docs. Now you might be wondering, what in the world am I doing? And what's that 2? It turns out that if you're already familiar with using the octal syntax of the chmod command, all right, if you're familiar with the octal syntax already, technically the octals actually have 5 placeholders, not just 3. So we don't really use the first placeholder at all for the most part. And so the second placeholder typically is not used, all right? So it's assumed to be a 0. And then, of course, the last 3 placeholders are users, groups, and others. Now, in this case, we are making use of the second placeholder. So we're going to say chmod. Now, the 2, I just happen to have this memorized, but the 2 makes it so whatever group actually owns this directory, it's going to auto-assign all new directories and all new content will be automatically group owned by the current group owner of the parent. So the docs directory is group owned by sysadmin. I say chmod 2 775 against docs. Oops. Oh, I can't do that because right now I'm Brent. In order to do this operation, I'll need to be root. Okay, now I'm root. Chmod 2 775. Now think about it for a second. Why couldn't I chmod it? Well, because I was Brent, and who owns the directory? Well, root technically owns it, so root's going to have to chmod it. So chmod 2775 on docs. All right, let's take a look at the long listing. All right, you'll notice something a little bit different now. You'll see a little S there. All right, and that means that the set group ID bit is set to being true. Now, the S does not mean sticky bit. The sticky bit is something different. It gets confusing because you see an S, you're like, oh, it's a sticky bit. No, it's not the sticky bit. This is the set group ID bit. All right, now that that's actually set, I'm going to switch users back to Brent. I'm going to go into the docs directory, and then I'm going to attach another script. Man, I cannot type tonight. Another script. Take a look at the long listing, and you'll notice that our freshly made script is automatically group owned. Now, this also works with subdirectories. So if I want to say, you know what, I'm going to make a subdirectory called scripts, because maybe that's where I should put all my scripts. When I take a look at that, you'll notice that the script subdirectory is also automatically group owned because the set group ID bit was set on the parent, and you'll notice that the set group ID bit is inherited. So once I actually set that bit on the parent, all new subdirectories, all new files, everything moving forward is going to be group owned by the group that actually owns the parent. So because the sysadmin group owns the parent directory of docs, everything inside of docs and all the new subdirectories and new files are going to automatically be group owned by the sysadmin group. That is probably one of the best things to learn, because now you don't have to tell Brent, hey, when you make a new file, you need to make sure you group the thing, or you don't have to tell Steve, hey, make sure you group your stuff. It automatically makes it so it is group owned by the appropriate group, which is great. Now, if you ever wanted to undo that, you would actually have to use the full syntax of saying chmod 00775, all right, against the scripts directory if you wanted to remove that. But typically, once you actually set that group ID bit, you usually want to keep that. Okay, so hopefully that makes some sense. So that is the set group ID bit. I'm going to keep going just for a little bit longer here. So that kind of solves the problem of things not being automatically group owned. But let's talk about one-off kind of privileges. Let's pretend we're going to go back to root now, and we're going to have an intern for a small period of time. All right, and they're going to be like a junior sysadmin intern for the summer. So what I'll do is I'm going to do a user add, and because they're an intern, I don't want to put them in the actual sysadmin group. All right, because if I did that, that would mean they can get to everything that my other sysadmins can get to. I don't want to do that. I want to explicitly allow them to do specific things on the file system. So user add, and who are we going to say? Let's say we have an intern named Mike. Sure, why not? Now Mike's a little bit of a wild card, so you want to be careful with what privileges you give him. He's eager to learn, but he might crash your system. So we're not going to give Mike all the privileges that he might wish he had, but we have to give him some. And this is where file access control lists come into play. Now, I think most of you have already at least read each other's posts or did some of your own research on how to use file access control lists. They're fairly simple, but the main commands you want to keep in mind are the set FACL command, and then the opposite to read them is the get FACL command. Okay, now we got this guy Mike, kind of a loaded cannon. You want to be careful about what he's allowed to get to. Now, in this case, Mike is an other, so he can actually CD into the docs directory, which is okay. But let's say inside of docs, I want Mike to be able to make edits to the script file, the myscript.sh. But for right now, I only want him to make edits to that one file and nothing else. So what I'm going to do is first I want to demonstrate that you do not have to be root in order to use the set FACL command. I'm going to switch users to be Steve, because Steve is our senior sysadmin. So Steve hears that there's this guy named Mike, and Mike needs to be able to make some changes to myscript.sh. All right. Well, first off, Steve's going to notice that we need to group that file just so it matches. So we're going to say sysadmin on myscript, because let's make it, oops. Did I misspell that? And myscript is on my brand. Oh, Steve can't group it because he doesn't own it. All these things, never assume anything. All right, so let's fix that. Root. There's an opportunity to show you guys something. If you're root, we can do things like group operations. I'm going to group to sysadmin everything that's inside of this directory. Boom. Now, of course, I'm root, so it works. Okay, cool. Now let's go back to being Steve. Sorry about that, guys. All right, so now I'm Steve. Let me reset the deck here. I'm Steve. There's this intern named Mike. I don't want Mike to be running around damaging things he shouldn't be damaging. He can already, because of the way the parent directory is set up, he can already CD into this directory, and he can read the scripts, right? So notice that Mike is an other. So as far as making changes to myscript.sh, Mike will be able to run it, right? Because he's got execute privileges and read only, but he can read and execute, but that's it. Now, I don't want to take and open up myscript.sh to be writable by everybody in the system either. So how do I make it so Mike specifically can have read, write, and execute privileges on that script? Answer there is the set FACL command. We're going to set FACL, modify. We're going to say the user of Mike needs to have read, write, and execute on what? Myscript.sh. And of course, I couldn't do that because who actually owns the file? Brent. So who do I need to be in order to take and set the FACL on this? Brent. So I have to call switch users to Brent, or I could be root, of course. And I'm going to say set FACL, modify, user Mike needs read, write, and execute on myscript. All right, now because the file is owned by Brent, Brent can take and use the set FACL command to then, and now if I do a long listing on it, you'll notice that the long listing output changes a little bit. Instead of a period here, you'll see a plus. So myscript.sh. Now, if you see a plus, that should be a red flag to tell you that the permissions, you need to look and use the get FACL command to get all the permissions. So get FACL on myscript. And here are the full permissions. User, read, write, execute. Okay. So user being the owner of it is Brent. And also now Mike actually has full privileges on that script. The group has that, and others can take and have read and execute, but that's it. Now essentially what that does is now I can take and switch users to Mike. As Mike, so who am I? I'm Mike. I can take and use my friend Vim. bash echo world. There we go. And you'll notice that Mike was able to make edits to that script with no problem. Now, can Mike make edits to, let's say, the README file? Let's try it. Vim readme.txt. No, I cannot, because look down here. Readme.txt is open read only. Sure, I can read it, but if I go to try to make changes, it will not save the changes because I only have read access to it. Because right now I'm running around as Mike. So now, let's say Mike's starting to prove himself a little bit more. And now I'm going to put him in charge of all the scripts. So not just the one individual script, but let's say I want him to have privileges within the scripts directory itself. So now I can say, well, first off, who owns the scripts directory? Now, Brent technically owns the scripts directory. So either Brent himself would need to take and use the set fackle command against the scripts directory, or obviously you could do this as root. All right, either way, you guys know root can do anything anywhere, but I really wanted to also highlight the fact that normal users can actually use the set fackle and get fackle command. So now what we'll do is we're going to switch users to Brent. Brent is going to, because Brent actually owns the scripts directory, he's going to say set fackle, modify. Again, it's the user of Mike needs to have read, write, and execute of the scripts directory. Long listing. Now you'll notice that the scripts directory has a plus on it, which means if I say get fackle scripts, I can take and see that Mike now actually has full read, write, and execute privileges inside of the scripts directory. What that means is that now I'm going to switch to Mike. And just to prove it, I'm going to go into the scripts subdirectory. There's nothing there yet, so I'm going to take and touch Mike's file. .sh. Let's call it Mike's script. .sh. And this is also an interesting behavior. Mike does not belong to the sysadmin group. So then you might be wondering, well, how the heck did this get group owned by the sysadmin group? Think about the parent directory. Look at the parent directory, it's scripts. The scripts parent directory. What is also set on the parent directory? The set group ID bit. So that's the deal when we did the chmod 2775. We did that on the parent. Well, then the scripts subdirectory inherited the set group ID bit, which means anything new created by anybody inside of this subdirectory will automatically be group owned by the sysadmin group. So even though Mike does not belong to the sysadmin group, and because he's an intern, he will not belong to the sysadmin group, his content that he just created is automatically group owned by the sysadmins, which is perfect. So now I have my intern Mike. He has full privileges within the scripts directory, so he can make scripts to his heart's content. Meanwhile, Brent and Steve, the two senior sysadmins, automatically get full privileges over everything Mike is creating, including subdirectories. So as Mike, I'm going to create another directory. And let's say I'm going to do some math scripts. You'll notice that also the math subdirectory, even though Mike created it, it's automatically group owned by the sysadmin group, and it inherits the set group ID bit. So anything new created within the math subdirectory will automatically be group owned by the sysadmin group. So this is a nice feature. The set fackle command, obviously I've shown you how to do it with individual users. You can do the same thing with groups. And instead of saying set fackle modify user, whatever, you can say group of web devs need to have, let's say they need to have read and write privileges within a certain subdirectory or something like that. You could do that with groups, you can do it with individuals. Now if you want to get rid of things, like you want to revoke fackles, and let's say set fackle, set fackle, The flag is -B, and I remember -B because I'm going to blow away. I'm going to blow away all file access control lists. So if you say setfacl -B and then give it the file or directory, that'll take and remove all of the access control lists associated with that. All right, so that's a good bit of material to kind of ingest. So we reviewed quickly making a user, making a group, made some directories, used the chgroup command. We did get into the chmod command. We talked about the octals. Now remember, the octals are the numeric way of setting the permissions, right? Just remember Yugo, user, group, others, right? Or actually it ends up being like you. So, you'll have 3, and you've already seen this before. These 3 are for the user, those 3 are for the group, and the last 3 are for others. So you can either do it with the GNU syntax, or you could take and use the octal syntax. I would recommend at least getting familiar with the octal syntax because that is 100% portable. You can use the octal syntax on any Unix, on any Linux, it doesn't matter, it'll all work. If you happen to be on a Unix like IBM's AIX, or if you're on a Solaris box, you will not be able to say chmod plus X. That's not going to work because that's the GNU syntax. You're going to have to say chmod, 755 or chmod 777, or you'll have to actually use the octals when you do that. And again, if you forget what the octals are and the digits of those, just remember man2chmod, and that'll pull up the man page with the octal information there. It actually goes into other things too, as far as using the set user ID bit. We're not going to cover that in this class at all, but we did use the set group ID bit. That's where that 2 came from. The first slot is not really used. I think they built that in to try to future-proof things, but it's never really used as far as the first slot. So the first field is never used. The second field is either a 4 for the set user ID, which we're not going to cover. The 2, like we did in chmod 2775, for the set group ID bit. Or then we talk about the sticky bit. Now again, we're not going to talk about sticky bit, but sticky bit is something different from the set group ID bit. Then of course we go down to what we normally consider the octals. So if you drop the first 2 leading zeros and just think about, okay, first is the user, all right, otherwise known as the owner, and then secondly is the group, and then lastly are others on the system. And you can see the numbers match up. 4 is read, 2 is write, 1 is execute. All right, I think it's good enough for now, and I will take and post this screencast, and I need to do another screencast talking about information security. You guys have been doing a nice job on your discussion board posts about security. Really fantastic posts. So let me take and make another screencast to talk about those. All right, thanks a lot, guys. I will see you online. If I can figure out how to stop my recording, I'd be even better off. All right, later.